Hello, and welcome to Algebra Unit 4-1, Lesson 1, Absolute Value. Our objective today is that scholars will analyze functions that include absolute value expressions. So today we're talking about absolute value. So the first question, what is absolute value? So absolute value is simply a number's distance from zero. For notation, we use the two bars around x to write the absolute value of x. So in order to write this on your computer, you are going to use the vertical line that is found above the enter key on the right-hand side of your keyboard. The key shows up like this, a vertical line, and underneath that line looks like this. So if you use your shift and then that vertical line is how you get that notation. An example of the value of -8, it would be written like this, absolute value of -8. The absolute value is going to be 8 because -8 is 8 units away from 0. So you'll see in practice what the absolute value function does is it removes negative values as the output of the function if we are simply looking at what's inside the absolute value. So what does an absolute value function look like? So we're looking at functions, which means we have two variables. So you see here we have y equals the absolute value of x. This is what we call our parent function. So if we were to graph this, its vertex is going to be there at 0, and then it's just going to be a straight line. Okay, I'm missing some points here. Hold on a sec. So it's going to be when x is 5, the output's 5, 10, the output's 10. When x is -5, the output is 5. When x is -10, the output is 10. So then we've got basically just a straight line there and a straight line on this side. So it looks sort of like a V is what our function looks like. So next, let's talk about the features of an absolute value function. So an absolute value function has an axis of symmetry, just like our quadratic functions did. So if you look right here, right down this center point is our axis of symmetry. We also have a vertex. The vertex is just this bottom point right here. In this case, it's 0, 0. Finally, we also have a rate of change. Now, the rate of change is actually constant on either side of our axis of symmetry. So my rate of change on this side, my rate of change is going to be 1. Every time I go up 1, I go over 1, up 1, over 1. If I go up 2, I go over 2. And on the other side, it's going to be -1. Every time I go up 1, I go left 1. Every time I go up 2, I go left 2. So on each side, the rate of change is constant. Finally, we have our domain and our range. So the domain of this function is, remember, domain is always your x values. Well, x can be anything. Going horizontally this way, it can be anything either way. So our domain is going to be between -infinity and infinity. Oh, and that doesn't look right. Should be more sideways. There we go. See if I can draw this so that actually looks sort of like an infinity. So there we go. So between -infinity and infinity. Our range, however, remember range is all the y values. You'll notice we have a minimum value. And our minimum value is 0 in this case. It's at our vertex. So this one goes between 0 and infinity. So our range is between 0 and infinity. Our domain, our inputs can be anything between -infinity and infinity, but our range is between 0 and infinity. So now let's talk about some different transformations. So what if I'm looking at this transformation where I'm looking at y equals -x? That negative in the front simply flips our graph. So instead of being upright, it's going to be the bottom. Our domain is still going to be -infinity to infinity. Our range now, though, is going to be -infinity to 0. Because as you see, 0 is now the maximum. So if I have a negative, I'm going to have a maximum value for my range. What about something like this? If I have the graph of y equals 2 times the absolute value of x, what that does is it simply makes my v more steep. My rate of change changes. So I still have the same there. It's going to look something like that. Again, my domain is going to be between negative infinity and infinity. My range is going to be between 0 and infinity. So when I multiply times a number greater than 1, it's just going to get more narrow. Okay, more narrow. Well, what if I add 4 to it? If I do the absolute value of x plus 4, absolute value of x plus 4, it is just going to move up 4. By adding 4, we move up 4. So instead of starting at 0, 0, I'm going to start at 0, 4. I'm still going to be moving the same slope, though. I still have my slope of 1 and negative 1 on either side. So now here, again, my domain is always going to be negative infinity to infinity. My range here, though, is going to be 4 through infinity. Because you see my minimum value is going to be 4. What if instead of adding, I subtract? If I subtract 2, instead of moving up 2, I'm going to move down 2. So I'll start down here. Same slope. Again, my domain is going to be negative infinity to infinity. This time my range, my minimum is at negative 2, is going to be negative 2 to infinity. What if instead of adding the plus 2 out here, I add the plus 2 inside? If I add the plus 2 inside, that changes this. Instead of changing it vertically, it changes it horizontally. So this is a horizontal transformation. It will actually move it 2 to the left. It moves it 2 to the left. So instead of starting at 0, 0, here, I'm going to be starting at negative 2, 0. So I start right here. I have the same slope. But I started at negative 2. So my domain is still going to be negative infinity to infinity. My range is going to be 0 to infinity. Notice that when I transform horizontally, it does not change my domain, and my range still has to have my minimum or maximum value, and then infinity on the other end. Now, what if I start combining these? What if I combine these? So, the plus 3 tells me that I'm going to go up 3. So I move up 3, right? And then the minus 1 tells me I move right 1. So in this case, my vertex is going to be right there. And when I draw it, I still have my same slope. Ooh, yeah. But, ooh, that's really messy. Let's try that again. So, go from here. Okay. So once again, my domain is still going to be negative infinity to infinity. I hope you're seeing a pattern on the domain. And in this case, my range is going to be 3 to infinity. So let's try one more. Notice I have a negative here. That means that I'm going to be reflecting it. I'm going to go down 2. So let's do this with red. So I'm going to go down 2. this red, down 2. So that brings me down here. And then this tells me I'm going to go left 1. So that means my vertex here. And then this tells me that I'm going to be opening down. So my vertex is going to be right there. And I'm going to be coming down right there. So again, my domain is still going to be negative infinity to infinity. And my range is going to be negative 2. Actually, let me go back. It's going to be negative infinity to negative 2. I always start with the lower number. Okay, so complete your practice, and then I will see you at your mastery check. Good luck.